Hi everyone, myself Dr. Lakshmi Prasad, working as a professor in CSC in Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about definition and terminology in graph roots. So the very first thing is that what is a Cosine-Berg bridge problem? So Cosine-Berg is a city on the Dundigal river in Persia. So the city is going to be occupied in two islands plus areas of both banks. And the problem is that so whether they could leave the home across every bridge exactly once and return home. So that is the problem here. So this problem can able to solve by designing graphs model, and then this problem is going to be solved. And next one, what is a loop on multiple edges? So loop is nothing but an edge whose endpoints are said to be equal, and multiple edges. That means the edges may have the same number of endpoints. Okay, so the edge loop is nothing but an edge whose endpoints are equal, and multiple edges means the edges may have same pair of endpoints. Suppose in this one these are the vertices, and the edge whose endpoints are equal. So starting is this, and then ending is also same. So this is a loop. Suppose I can able to draw one more loop. Now this is in case of undirected one. Suppose if I'm going to draw in directed, I can able to draw like this. And multiple edges means so I can able to draw in between the vertices. I can able to draw multiple edges. If I'm going to draw, then I can able to say this should be the multiple edges. So the lines which is going to show as blue, so these will be the multiple edges. So the edges may have same pair of endpoints. Then what is a simple graph? So simple graph means a graph has no loops or multiple edges. So suppose if I'm going to take a graph like this, this is the simple graph example. Why? Because if the graph may not have loops and then parallel edges in between the vertices, so that's why I can able to say this should be the simple graph. And this may not be a simple graph because it is going to contain the loops and then parallel edges and all, so that's why it should not be a simple graph. So simple graph means that so the graph which is going to have no loops and parallel edges, I can able to say this should be the simple graph. Then how can I able to say that the two vertices are adjacent and the neighbors means? So if they are the endpoints of an edge. Suppose if I'm going to draw an edge, so if I'm going to draw any two endpoints in between the end of the edges, then I can able to say A and B are adjacent to each other. So in this graph, given graph, so A, B, C, D are the vertices. So A and B are adjacent because those two vertices are connected by means of an edge. So this A and B are said to be adjacent or neighbors. So in this one, so A and D is not adjacent by because there is no edges connecting between A and D. So that's why A and D are not said to be not adjacent. So what is a finite null graph? So finite graph means that a graph whose vertex set and edge set are said to be finite. A null graph means the graph whose vertex set and edges are said to be empty. Okay. So what is a finite and null graph? A finite graph means that a graph whose vertex set and edge set are said to be finite. A null graph means a graph whose vertex set and edge set are said to be empty. Suppose if I'm going to draw a graph like this. So the vertex set should be A, B, C, D, and edge set should be E1, E2, E3, E4, and E5. So finite graph means, so this is one of the example of finite graph, right? Because the graph is going to have the vertex set and edge set should be the finite one. So this should be the finite graph. So the graph which may not contain any vertex set and edge set should be empty, I can able to say this should be a null graph. So what is QQ and independent set? So QQ in a graph means it should be a set of pair of adjacent vertices, or I can able to say this should be the complete subgraph. An independent set in a graph is nothing but the set of pairwise and non-adjacent vertices. So QQ in the graph means that it should be a set of pairwise adjacent vertices. An independent set in a graph means a set of pairwise non-adjacent vertices. So QQ means a set of pairwise adjacent vertices that should be a complete subgraph. An independent set of the given graph is nothing but set of pairwise non-adjacent vertices. So example here. So x, y, and x, w, x, y, u. So this is the QQ in the graph. And u, v are said to be independent set. So the set is set why? Because those two vertices are not correlated with each other. So that's why u and w should be the independent set. And a complete set of pairwise adjacent vertices should be treated as QQ. What is bipartite graph? So bipartite graph means if the vertex set of the graph is the union of two disjoint independent sets, I can able to call it as a partite set of G. So a graph G is said to be bipartite. So if the vertex set of the graph is the union of two disjoint independent sets, called as partite set of G. And this vertex set should also be partitioned into two sets, so such that each set is independent. Right. Suppose I'm going to have the vertex set like this. So I'm going to divide this vertex set into two sub partitions of the set. So based on the criteria, and if I'm going to map in between those sets, I can able to say that should be bipartite. Okay, matching problem and then job assignment problem mainly when the bipartite graph is going to appear. Suppose if I'm going to have a set of vertices that should be a category of boys, and another set of vertices I'm going to have that should be a category of girls. So similarly, if I'm going to have workers and then jobs, so the matching is done in between the set of different vertices of the vertex set, then it should be bipartite. And next one, what is a chromatic number? So chromatic number of the graph means that which is going to be defined as x of g, which should be the minimum number of colors needed to label the vertices such that adjacent vertices is going to be received different colors. So the chromatic number of the graph G is written as x of g, that should be the minimum number of colors that are needed to label the vertices. Suppose if I'm going to have a graph like this, so I'm going to mark with blue here, and the adjacent should not be blue, or so that's why I'm going to mark it as red. And since these two are going to be mapped with green here, so these two may not be equal, so that's why I'm going to mark with green. And if I'm going to consider this, so the blue is not adjacent to green and the blue is not adjacent to red also, so that's why I'm going to mark it as 3. So how many colors are needed for this graph? 3. So the chromatic number of the graph is 3. So what is a map and coloring? So map is the partition of the plane into connected regions, and we can able to color the regions of every map using at most 4 colors, and then map coloring is said to be graph coloring. So in the graph coloring, so the regions are going to be considered as the vertex, and adjacents are going to be considered as an edge. So map coloring and graph coloring is something different. So map coloring means it should be almost all similar to graph coloring, but mainly the thing is that the regions are going to be considered here, and edges is also considered as an adjacent is going to be considered as an edge. And next one, what is a path and cycle? So path is nothing but a sequence of distinct vertices such that two consecutive vertices are said to be adjacent. So, for example, if I'm going to have the graph like this, so the path may be A to B, B to C, C to D, and D to E. This is the path. Okay, so the sequence of distinct vertices such that two consecutive vertices are to be adjacent. And so A, B, E, D, C, B, again E, D. So this not be a path, this should be a walk. So that is the difference between the path and walk here. And cycle. So what is that? Cycle is nothing but the closed path. So in this closed path, the source and destination should be same. So whenever the source and destination is same in between this, then I can able to say that should be a closed path or it may be a cycle. Okay. So if I'm going to have a graph over to C, so I'm going to be started from A and reaching B, and from B to C, C to D, D to E, and then E to so A to B, B to C, C to D, E to E. So here the source and destination is same, so that's why it should be a closed path. Suppose if I'm going to be start at B, so B, B to C, C to D, D to A, D to A, and again A to B. So this should also say, so the another path for reaching the vertex B. And next one, what is the subgraph here? So subgraph of the graph is the some part of the graph what we're going able to extract it. So that means the vertex the graph is going to have G should be the subgraph of this, means the vertex set of this H should be subset of vertex set of main graph G, and the vertex set H set of H is also going to be subset of H set of G. So a graph is said to be some part of the graph what we extracted from that. So subgraph is that, so A, D, and C. Some particular portion of the part what I'm going to consider that should be the subgraph of the given graph. So some of the subgraph what I shown here is that, so this is the given graph and H1 is one of the subgraph, so I'm going to consider this part, and so H2 is nothing but this part I'm going to extract it, and H3, so this part and this part, that should be also a subgraph of the given graphs. So how are going to say this graph is connected and disconnected means, so whenever there exists one path between the vertices, I can able to say that should be connected one, otherwise it should be disconnected. So H1 and H2 are connected because so all the vertices are connected by an edge, right? So when it comes to H3, so there is no connection between from A to B and A to D. So these two are separate ones. So I'm going to say this graph is said to be disconnected. So there is no proper connection in between this here, A to B and A to D. So what is adjacency matrix? So adjacency matrix of the graph is going to be defined as an by a matrix in which the entries should be the number of edges and with the endpoints I am reaching. Suppose if I'm going to draw a graph, so the vertices are going to be considered along the rows and then columns. So whenever I'm going to have an edge from A to B, I can mark it as 1, and A to C also 1. So there is no edge, that's why it should be 0. So from B, I'm going to take B to A, B to B, and B to C is 1, and then C to A and C to B is 1. So like this are going to be constant. Suppose if I'm going to have the multiple edges in between the graph, then I can represent 2 here. So x to y, I'm going to have 2 multiple edges in between them, so that's why I'm going to mark it as 2. Similarly, y to x, so y to x also be 2. So if there is no x from W to Z, so I'm going to mark it as 0, right? And what is the incidence matrix here? So incidence matrix means, so it is also a matrix in which the entry should be 1, and if the vertex is an endpoint of E1, then otherwise it should be 0. So the entry should be 1 whenever the vertex is an endpoint of that edge E. Otherwise it should be 0. So take W. So W to, so I'm going to be considered in matrix vertices, set of vertices, and edges should be as columns. So these are the vertices and these are the edges. So in between this, so I'm going, what is the edge W or vertex W is going to have? A is there, B, and then so those two edges is going to have for the vertex W. So that's why this should be 1, otherwise remaining all should be 0. Similarly, if I'm going to consider X here, so what are the edges that are connected? B. So for X it should be A, C, B. So A, C, D should be 1. So remaining all should be 0. So if I'm going to consider Y, B, E, B, C. B, E, B, C. So this should be 1, remaining should be 0. For Z, only one edge is connected, that should be B, it should be 1. So the incident matrix is the matrix which is going to be mapped along the vertices and edges here. So what is isomorphism? So isomorphism of the graph G is a simple graph which should be a bijection, and we can be able to say G is isomorphic to H. So if I'm going to have mapping like this, so X, Y, X, W, X, Y, and Z. So for this similar also I'm going to have, so for W I'm going to have C, for Y it should be D, and X it should be A, and Z should be C. Okay, so if I'm going to go for in this direction, so similarly for C I'm going to have, and D should be Y, and A should be X, B should be Z. So then I can able to say those should be, the two graphs are said to be isomorphic. What is the complete graph here? So a complete graph means a simple graph whose vertices are pairwise adjacent. Supposing the number of vertices in the graph should be 6. For each vertex, there should be an edge that is going to be connected. So if I'm going to consider this, I'm going to consider this, I'm going to consider this, I'm going to consider this. So for each vertex, there should be an edge that is going to be connected for every vertex. if I'm going to consider this one, so then I can able to say this graph is said to be incomplete graph. What is complete bipartite graph? So the complete bipartite graph is a simple graph such that the two vertices are adjacent if and only if they are in different partite set. So with a simple bipartite graph such that the two vertices are said to be adjacent if and only if they are in different partite set. So what is the path here? So a UV is nothing but a path that may be a trail that has a vertex, first vertex U and the last vertex should be V. So these are the endpoints. So the length of the walk of trail or path or cycle is the number of its edges. And the walk or trail is closed if the endpoints are said to be same. Okay. So the path is nothing but the sequence of adjacent vertices. The length of the path is nothing but the number of vertices, edges in between them, and the walk is said to be closed whenever the source and destination should be same. The next one, what is a component? So the components of the graph are its maximal connected subgraphs. And component of a graph is trivial if it has no edges, otherwise it should be non-trivial. Okay, so the components of the graph are said to be maximally connected subgraphs, and the component or a graph is trivial if it has no edges, otherwise it should be non-trivial. Then isolated vertex. So isolated vertex, the vertex of degree 0. Next one, what is Euclidean circuit? A graph is Euclidean if it has the closed trail connecting all the edges. And we can also call the closed trail a circuit when we do not specify the first vertex but keep the least cycle for it. And then Euclidean circuit and Euclidean trail in the graph is the circuit or trail containing all the edges. So a graph is said to be Euclidean Euler's graph if it is going to have Euler circuit and Euler trail. So Euler circuit and Euler trail is a circuit or trail containing all the edges. A graph is a Euclidean if it has closed trail containing all the edges, and Euclidean circuit or Euclidean trail is nothing but the number of edges. So what are strongly and weakly connected graphs? The graph is said to be weakly connected if it is underlying the graph is connected. A directed graph is also called as a digraph, which should be strongly connected. So for each pair of vertices, there is a path from U to. Then Eulerian digraph. So Eulerian trail in the digraph is the trail containing all the edges, and Euclidean circuit is the closed trail containing all the edges, and a digraph is Euclidean if it is half Euclidean circuit. So Euclidean trail is nothing but the trail containing all the edges. Euclidean circuit is a closed trail of all the edges in the graph. So Euler circuit and Euler path. So when a graph is going to have no vertices of odd degree, then it should have at least one Euler circuit. So whenever the graph is going to have exactly two vertices of odd degree, then it should has at least one Euler. So there is no Euler circuit or Euler path here, and there is no possibility that you can able to travel all the edges of the graph without having to cross some of them more than once. So regularizing graphs. So these are the different ways of regularizing graphs. So first step we have to identify the odd vertices, and then second step we have to add the duplicate copies of the edges to create the even vertices. And semi-regularizing graph means that so first step we have to be identify the odd vertices here, and then second step we have to be lay out these two vertices and add the duplicate copies of the edges. And what are the applications of this means Chinese postman problem and then communicating networks and stuff. So these are the applications of the graphs.
Like, share, and subscribe. Hit the bell icon for more updates.